Welcome to Programming with Qt Widgets. This is a day you've all been waiting for since we started releasing this series, namely the day where I would really dive in to talk about model view. You tried previews, you tried implementing your own QAbstractItemModel subclass, right? And did you fail? Chances are pretty good that you did, that is. So what is model view all about? Well, on a very, very high level, the model is your data, the view is the representation. And just for the fun of it, I found this book in my shelf. You have that at home too, don't you? You don't know what a book is? Oh, gee. Well, this is the book for elderly gentlemen like me. I bought this book, I can tell, because I wrote dates in the book when I read each chapter. So I must have got it just around 2001. And already on page 4 in this book, it describes model view. And let me just read it out for you, just so you have an idea what we're talking about and why this is so confusing for many people. It goes like this. Model view controller consists of 3 kinds of object. The model is the application object. That translates to, that's where your data is stored. Okay, fine so far. The view is its screen representation. Okay, so that's Q checkboxes, Q line edit, Q whatnot. And the controller defines the way the user interface reacts to user input. Wait a minute. That was my reaction back in 2001. That does not compute. Because I had a toolkit in front of me, and this was the Qt 1.44 days, or 1.2.0 when I got this book here, and Qt already had the data. My checkbox have the data. When in the paint event of my checkbox, it goes and reads a variable that it has an instance variable inside it that says whether it's checked or not, and paint the checkbox accordingly. It doesn't go to a model, so it did not compute for me. Many years later, when Qt 4 came out, I finally understood much better what they were referring to. And it could relate to it in Qt, because there are 3 special cases where model view makes sense. It doesn't make sense for a regular dialog or whatever, but it makes sense for 3 cases, namely lists, tables, and trees, because they consist of a number of items that are repeated over and over again. Well, the items is not, the data of the item is not repeated, but the whole setup. It's the way that you paint and whatever. The first item in your list box is exactly the same way you do it for the second, and so on and so on and so on. And there it makes sense. So with Qt's model view framework, the model is a class that provides the data to the view. And we have 3 views. We have QList view, QTable view, and QTree view. And they can read from the model. The view themselves actually do not do much work. I'm sure that's not true, but they don't do as much work as you would expect, because the cells inside the table, for example, is painted by the delegate. Profiling is easy, right? You just find wherever your application is slow and you fix it. Or maybe it isn't that easy. Maybe you need to understand exactly how to apply the tool. Take a training from QApp to learn exactly that. I have seen a lot of people out there doing model view over the last, 15 years. And I've seen a lot of people conceptually get it wrong. I don't think it should have been called model view to start with. Of course, that is a good hype value, at least 15, 20 years ago it was. But the problem with the model view is that you think that you store your data in the model. But that's not what it is. The model is not for storing your data. The model is purely a converter of a kind. It should have been called something like converter view or proxy view or whatever. What the model does is that it translates your real data. And I would like you to pause me right now and think of what... You shouldn't pause me before I was done giving you the assignment, silly you. In a minute, I would like you to pause me and think of what kind of data do you have that could be represented in a list, a table, or a tree. Welcome back. I'm sure that your answer was not something that was already sitting inside a model of some kind. Let me give you a few examples here. For example, I've implemented an application for managing your photos. I started that 20 years ago before the Model View framework, but that's beside the point. So inside of this application, I have obviously a list of thumbnails. That's this larger pictures in small format, and the list view is in icon mode so that they spread out nicely over my screen. Do I have those in a model somewhere? No, I have images on my hard disk. My model purely translates in a language the view understands. The view can go to the model and say, hey model, can you tell me how many thumbnails do you have? Of course, it doesn't ask that because it doesn't know about thumbnails. Just say, how many rows do you have? And the model will say, actually, I have 29,000 rows. And you will say, ooh, that's a lot, but I'll just paint a scroll bar somewhere, and then you'll go down and start, can you give me the first thumbnail and the second, and so on. And then the model will be doing the translation. Oh, you want the text for the 350th item row in the model here? I can do that. I can go and look at my disk and find the 357th file, and I can figure out the file name, and that is the text that I'll give you for the text there. Model view makes you think that your data is in the model, but they don't necessarily need to. In my class, I usually tell people to imagine that what we are talking about are satellites. Satellites orbiting around Earth, and I looked it up at some point. There is approximately 2,000 of those. So satellites orbiting around Earth is not something you can easily get access to. So it will be super slow to ask them about things. So first of all, you need to know how many satellites there is. So you'll call NASA, and you'll call the Russian version, the Chinese version, the European version of space agencies, and ask them for how many satellites there is. And once you have that, you can tell your view there is 1,985 satellites. And then you'll go and say, okay, the first one, what is the name of that one? And then you will, with a TCP connection, call NASA and ask for the identifier for the first one, and you will answer that. And for the next one, and you'll do a TCP connection to somewhere in China, and they will tell you the second one's text, whatever. I'm just making it up, and hopefully you do cache there. But the key thing is that the items are not inside the model. There are a few models where you can actually store the data in, but for most of the cases, the model is an interface to your real data. And that's actually what the next slide here shows you. It shows you QAbstractItemModel sitting there being the interface between the data and the views. And we have a number of different views in Qt. We have QList view, QTable view, QTree view, QColumn view inside of Qt Widgets. Qt Quick can be a view. There are a number of classes in Qt Quick for that. And then it says C++ components. And one of the cool thing, or one of the curses, depending on how you see it, of the Model View framework in Qt is that you can create your own models that is going by the name proxy models. A proxy model is something that talks like a model, and it talks like a view. So basically, you have a view here, you have a model here, and in between, you put a proxy model. The view talks down to the model on the layer below it. It asks how many rows, how many columns, whatever it asks. And that model, the proxy model, talks into the model underneath it and asks it a number of questions and returns some answers to the view above. And the key thing about these proxy models is that it's a super good separation of concerns. So if you have, say, I have in my data, I have some models that represent money month by month by month. But there are people that would rather than see a plot that goes from January 2000 to December 3000, they would rather see it year on year, which means that instead of just having one long series of data, I would have a number of series, one for each year. And so column 0 would be January 2000, February 2000 up to December 2000. Column 1 would be January 2001 up to February 2000, and so on. That is relatively easy to implement with a proxy model. So I'll have my model untouched, not knowing that it also needs to provide it as year on year. And then there is this proxy model that just slips in between, and now my data is presented in a completely different way. One of the key problems, and I said it's either a blessing or curse, in Qt's model view framework is exactly these proxy models. Because to be able to have these proxy models come in between anything, it means that the models need to inherit from the same superclass. And the superclass for any models in Qt is called QAbstractItemModel. And there is a subclass of that is called QAbstractListModel. If you want to implement a model with only providing one-dimensional data, well, that is relatively easy. You'll subclass from QAbstractListModel, but you need to implement stuff. You need to answer, for example, how many rows are there? How many items are there in your list? But the method that you need to implement takes a parameter QModelIndexParent. And that's the first time where you're like, what? Well, yeah, QAbstract or QModelIndexParent, that is for the tree case. So if you look at my screen here now, you'll notice that this is the list version. There is no parent. There's just a number of items. And this graphic here indicates that there is an item sitting above all the items. That's a root item, conceptually at least. Here's my table, and I don't know what these dotted lines are supposed to indicate. This is an image we stole from the Qt documentation 15 years ago. And over here we have a tree. And here's a number of items, row 0, 1, and 2, and underneath the row 0, there's row 0 and row 1 again. So there, it makes sense to answer, is it this item we're talking about? How many rows are there? 3. Or is it underneath this one? How many are there? Well, in this drawing, there's 2. But for the list version, you don't answer that. Well, you have to answer that, but you don't use the QModel index given. You just throw it away. And that is the part that makes model view, even for simple list, somewhat hard. But hey, you're watching this now, so in an hour or so, it will all be crystal clear to you, hopefully. We have 3 different dimensions, as it says here. We have list models, they only have rows. We have table models, which has rows and columns. And then we have tree, not 3, but tree. Can you zoom in on my mouse? 3, that's a number, and tree, that's what is in a forest. And the tree model, those have row and column. There could be multiple columns here, and a parent telling where in the tree are we located. Obviously, the data in the models are only for the mice running around inside of your computer to see. They are just data in memory, and nobody can see those. So to visualize your models, you need a view. And the cool thing about the model view framework is that you can take a tree view, or rather you can take a tree model. Those are the QAbstractItemModel subclasses, or, well, certainly subclass because it's abstract. But you can take one of those models and you can put it into a list view. And then it will just show one level of that tree. You can There's even API for specifying what should be the parent there. That's not really the point here. But you have a number of different views. And you can see here we have a QList view. It goes best with a list model. We have down here a table view, and then the last one is a tree view. And I think we have no more, but I might be wrong, than these 4 views. So the QAbstractItem view, that's a superclass of all of these. It has a number of methods involved for, well, general view stuff. Then we have the list view, the tree view, the table view, and we have the column view. We also have the header view, and we'll see that a bit later on. We already saw it in the previous episode. QHeader view, yes, it has the same way of communicating with the way we'll see in the upcoming, but obviously upside in my header here, I cannot have a tree inside my header. So there's only one row that the QHeader view support. And it doesn't even support it via the data method that usually is done. It does it via header data, but that's for an upcoming episode. But before I leave you now, and before I give you my closing word of the stuff to remember, let's just see this example we have here. It is as simple as it possibly can get. It is a model view that is connected to a view. So I have my main here, a Q application app. You've seen that numerous times. I start my event loop down here. I create an instance of the class Q column view. I create a model. That's the Q file system model. And I do stuff here to the model. And in the end, I say view, set model, model. So I tell my view that it should get its data from this model. And that's really all there is to it. We can start browsing my hard disk here if I want to. User, where do we want to go? Apt, whatever. The key thing, however, is that there only exists one model out there in the wild that you can use, namely Q file system model. Every other model is something you need to implement. You need to implement a model that knows. Remember, you need to implement the proxy object, the converter object, the whatever you want to call it. The model that knows how to go and call NASA and the European Space Agency and whatnot to get that data out. Or go to your hard disk and read those thumbnails or those images and convert them into thumbnails. And that model, you need to write that for your particular data. And that's what the majority of the rest of this training is all about. So welcome on this journey to the model view land of Qt. We will talk a lot about a lot of different things. We will talk about views. How do you actually customize those views? Relatively boring. And you will very, very seldom implement your own views. I've seen perhaps 2 or 3 views in my 25 years with Qt by now. Not something you do. We have the QList view, the QTable view, the QTree view. They do an excellent job. But you might sometimes want to have something rendered slightly different. So you have a money class that you want to paint, and it should be painting it in a special way where however you paint your currencies. And when you click on it, it should be possible to change from euro to dollars or whatever by some mechanism. And that is what the Delegate about. I've created, 20, 30, 40 delegates in my lifetime. It is something that you do from time to time. And there is a good piece of work to that, and we'll talk about that a bit later. But the key thing is, to the model view framework, is that you need to implement this proxy model to your data. The interface that can answer information about your data. So the view will say, hey model, can you tell me how many rows are there? And the model will say, well, there is 12 rows. How many columns are there? There's 10 columns. We're assuming it's a table now. If it was a tree, it would the narrative would be slightly different. If you would say, "Hey, model, can you tell me how many rows do you have at the top?" And then we get to an item somewhere deep down and say, "How many rows do you have underneath this item?" And that's the API that you need to implement from the model. You also need to be able to answer information about the data. Like, "Hey, model, I would like to know in this particular cell in my spreadsheet, what should I type in there? And what color should it be? And should the background color be different? How about the fonts? How about," and a lot of other things. Those things is exactly what we'll be talking about in the next episode. So stay tuned. And until then, have a great time.